Okay, hi. In this video, we'll be learning something called as data link protocols. Now, as per the syllabus, you need to learn two data link protocols, something called as BISYNC protocol and something called as HDLC protocol. Okay, now HDLC protocol will take in next video. For this video, we'll talk about BISYNC protocol. This BISYNC protocol stands for binary synchronous communication data link protocol. In short, it is called as BISYNC or simply BSC protocol. And there are some features that you need to know over here. Now questions can come for a semester exam. What are the features of BISYNC protocol? And or it can be asked to compare, differentiate between your BISYNC and HDLC. So there is where all these features are important, because you can use these features for comparing them. Okay, now here it is a byte oriented protocol. As we have already discussed this in class, that the protocols are of two types. One is byte oriented and one is bit oriented. Byte oriented meaning what? Now all the fields which are there in the frame are at least one byte or multiple of the bytes. So this is a byte oriented protocol. It supports three code sets, that is ASCII, EBCDIC, which stands for extended binary coded decimal interchange code, and transcode. Now it supports synchronous two-way alternate communication. Now this thing can be used. Now if you compare this protocol as with the other protocol, this is a byte oriented protocol, that might be a bit oriented protocol. Here nowhere it is written that it supports asynchronous, but asynchronous protocol. So you can write that it supports asynchronous, and there maybe it can support asynchronous as well as asynchronous. Here it only supports a two-way alternate communication. There it might be different. So all these features you need to know. Okay, and it is applicable to point and point to multi-point communication. So again, a small recap. It's a byte oriented protocol. It supports three code sets. It supports synchronous and two-way alternate communication, and applicable for point to point and point to multi-point communication. Now there are several variants of this protocol. The one we'll be discussing is having numbered acknowledgements, unnumbered frames, and inquiry command if there is no reply from the save. Next topic that we have to study is something called as communication modes. So it supports point to point and point to multi-point mode of communication, that is one to one and one to many modes of communication. There is a master-slave relationship between the two communicating stations. That suppose we have two stations that want to communicate, and then station A wants to send data to station B. So there is a master-slave relationship between the two. Now who becomes the master? The station that is actually sending the data becomes the master. The other station which is actually receiving the data and sending acknowledgements becomes the slave. Okay, so the person or the station who is sending the data is the master. The station that is receiving the data is designated as a slave. Okay, now there are two modes in which it can work. One is point to point, that is between the two hosts, two people want to talk or two host stations want to talk, and point to multi-point modes of communication. Here we will be discussing point to point communication. Point to point communication is between the two hosts. Okay, and whichever station wants to send the data, it will try to contend for the master status. Okay, so what happens is that one of the stations is designated as a control station, which will delegate master or slave status to the other depending on which the station want to transmit the message. So it is like in this point to point communication between the two hosts. Okay, and then whichever station wants to transmit the data contents for the status of the master. Okay, and then one of the stations act as the control station, and then that station will finally decide who becomes the master and who will become the slave. In point to multi-point communication, one to many, there is one host and several tributary stations. Now, important, the host decides who will send or receive messages. All the messages are sent by or to the host. Okay. Now, Now this is in point of multi-point. This is done using two methods, something called as polling and something called as selecting. Now it is like if two people, if two systems want to exchange data, now there can be two things. Either suppose we have a host and there is a tributary station, so the host can tell the station, ask the station whether the station wants to transmit the data. That this is called polling. And if the host tells the station, tributary station, that that the host wants to send the data, please receive it, then and it becomes what now? Selection. Okay. So in multi-point communication, the host invites a station to transmit data by polling. So it is like it requests if the station wants to send data, that is called as polling. Now if it actually wants to send the data, the tributary station, then since it is sending the data, it becomes the master station and it controls further communication. And after it has sent all the data, after the completion, it will return, it will give control to the host. Now if the host actually wants to send data to a station, it alerts the station to receive message. Okay, and this process is called as selection. Okay, now since the station, the tributary station is receiving the data, it becomes it becomes slave station. Now transmission of frame. Now BISYNC frames are called as blocks, but I will not confuse you with this, so we will be only calling them as frames, but you should remember that they are called as blocks. Now these frames are of two types, one is supervisory frame and one is data frame. Supervisory frames are used, these frames are used for sending control information. Okay, and this is important what I will be telling you, and are not protected against content error. Now this might be this you can use when if a question for differentiation between BISYNC and this is asked, this is asked. So supervisory frames are used for sending control information. The important point over here is to stress is they are not protected against content errors. Okay, and the second frame is called as data frame. Data frame contains user data and contains error detection bytes already. Okay, this we have already discussed. Now frame format. Now it is, now this we have already discussed. This BISYNC is a byte oriented protocol, meaning what? Now the fields which are there in the frame at least are of one byte or multiple of those bytes. All fields are in multiple, same thing what I have explained. BISYNC employs variable format, variable size frame, meaning what? Now the format is not fixed and the length of the field is also not fixed here. If the format is not fixed, how does the receiver know what is the next field that is going to come? So if it is to know, it will require something called as a field identifier to identify which field it is coming, and we also require something called delimiter to tell the receiver that the particular field is getting over. Now here we have two kinds of frame, something called as supervisory frame. We have already discussed some supervisory frame and data frame. Okay, and then the first we have something called as frame identifier. It will, so when this is received by the receiver, synchronizing characters are received by the receiver, it will understand that the frame has come, but still doesn't know whether it is a supervisory frame or it is a data frame. Okay, now the next field in the supervisory frame is the address field. It is only present in the, this is optional because it is not present over here. It is only present in the supervisory frame sent for polling and selecting in point to multi-point configuration. It is always the address of the tributary station. Now how does the, now with this address the tributary station know, I can find out whether it has been polled or it has been selected. If the address in this particular field is in capital uppercase, then it is a poll frame. If the address in this particular field is in lowercase, it is a selector frame. So with this address comes to know whether it is polling or selecting. Okay, if it is an uppercase, it is polling. If it is polled frame, if it is lowercase, it is selection. Okay, now coming back to this control field. Control field contains control bytes for link management error control and flow control. So here we finished supervisory frame. So these two characters will tell that the frame is coming. Next is address, always the tributary station address. Capital uppercase it is fold frame, lowercase it is select frame, and it will have control, and this this will have control bytes for link management, error control, and flow control. Now here, okay, now since it is variable format, it has to tell the receiver what is the next field that is coming. Okay, so for this heading we have identifier called as SOH. It stands for start of heading. Okay, this will tell the receiver that the next field that is coming is heading. Okay, heading field contains information for higher layer functions such as message identification, routing, priority, and device control. It is optional because it is always present in data frame. It is not present over here. Okay, and it is the identifier is as start of heading, and the delimiter is the identifier for the next particular field. Okay, the next field is something called as a text field, here where the user data is present. Okay, the identifier for this text field is stx, start of text, and the delimiter for this field is etx. Now here it can be etx or etb. We will study this properly. Suppose a message is divided into 10 parts. So how does the receiver know that the message is getting over? So for the first 9 parts, this particular this will be ETB. So if it is ETB, it will understand that there is one more frame to come. If it is ETX, it understands that it is the last frame. Okay, and finally we have something called as block check characters. It is used for content error detection. Okay, so this we have already discussed. Some control characters, this we have already discussed. Sync, start of heading, start of text, etb, and a block or etx. Okay, now this inquiry control character is very important. Okay, now it has many functions. Now it is used during the link establishment phase to activate the other end. So it is like when two station wants to communicate, or one station wants to communicate with the other station, it will send an inquiry command to activate the other end. So okay, this is one thing. Second is the host polls or selects the tributary station by sending inquiry. We'll see this later when we are actually dealing with how frames are sent. Okay, so you need to remember that the host polls or selects a tributary station by sending inquiry. Okay, when there is communication between the two hosts, inquiry command is used for gaining the master status. Okay, so the master status is gained from this particular control character, and then it is also used during the data transfer phase to challenge the other station after a timeout if no acknowledgement is received. Okay, suppose one station has sent some data and no acknowledgement has come from the other end, then it is used to actually challenge the other station whether it is received properly. Okay, finally end of transmission. End of transmission is usually at the end, that will tell the other end that it has finished transmitting the data. Okay, and since your BISYNC uses stop and wait flow control mechanism, it will have all this ACK0, ACK1. This we have already discussed, NAC and VAC. DLE I will see later on. Okay, so error and flow control. It uses your stop and wait flow control mechanism for error as well as flow control mechanism. So all those things what we have studied for your stop and wait are applicable here. Okay, so with this I stop this video. We'll continue it in the next video. Okay.